the right equipment, it would have worked. What happened here? We invested money which is not giving the right result. You are in non-compliance. If you are caught, you will be penalized, right? So here it is not the mistake of saving money. It is that you do not know the knowledge, and second thing is being misled by, or maybe you are entering the non-compliance zone. So one on the bottom there is another gem. If you see the wires, right? So that is a new kind of analyzer, have never been invented till date. So but that plant had. So it was in Delhi NCR. I had an option to visit some of the plant that was for the NGT. So figure out how these things are working. So I got this plant there. So the data was coming perfectly in all compliance. When I get to see where it is installed, so one of my colleagues, when I asked them just to see why it is so perfect, and there's a smaller plant. So on the top I got this is the installation. So there is no probe inside, but you had data. And at the end, when I say that when you installed it, have you done the calibration, etc.? So perfectly, yes, we have done the calibration. So when we went up on the stack, there was no another hole. So calibration, how calibration is done? So calibration is you have a monitor, SAMS, and in parallel you do gravimetric monitoring, right, for the gas or for the PM. So that stack didn't have any another hole. So how did you calibration? So it's all gone. So what had happened, the person who had installed here, he found a hole already there for the gravimetric monitoring where the lab was used to do. So he didn't make another hole, so he used that hole to fix that. And the plant didn't know there is no hole left in the stack. There's another James, it still happens in the smaller plant, still I have seen. So the first one which you saw, when I say that it is stagnant, and when I saw the record of the last 1 month data, so there was variation when the equipment was not working. So when I saw how the data acquisition system and handling system it is connected, when I get to find out, finally he handed up. So this is the system he had. So some of the vendor had handed over this system. So here you see, so he showed me, sir, we have the variation of the data. So you see there are 3 holes. So if we need to have the higher data, we put the plug in here. If we need middle one, we plug in here. And if we have to show the data lower, then we plug in here. He declared everything because he know that he has been caught. So this kind of system I had found long back, but I'm still sure there are many in the smaller plants. It is still there because it is not non-compliance or cheating done by industry. Industry doesn't know that there has been a problem in the system created by whom you have asked to install. Many of the times, industry will not take risk of doing this kind of stupidity. Normally, I'm not giving clean sheet to everyone. Yeah, so one of the big plant. On that side, you see there's a PM installation done. So what is happening over there? There are 2 stacks coming, 2 ducts are coming and joining to the stack, right? So it would have been ideal that you install in every duct, you monitor there and get the data, both the duct. Or you install in the stack and you get the data. So here the idea was that flue gas is coming from one duct, coming from another duct. If you have to represent both, then you have to install 2, right? And if you install in the stack, there's a possibility you do not have the right space, or stack is not enough to make the drill and all. So he thought the best solution is install in between. So it is representing everything, right? That's the idea. If you see, they have installed in between. And the data was, frequently varying like anything. So why it is the wrong spot? Can anybody tell us? Why it is the wrong spot to install? Yes. So more or less in the entire plant, that would be the worst place to install. So he chose the most convenient place. So because you see that flue gas is coming from one and joining there. So there again there is a turbulence. It is opening in the larger duct. Again it is turbulence. There are cold spot, turbulence. There is no isokinetic, no homogeneity, nothing. There is no laminar flow, and here it installs. So how can you see the representative data there? Equipment has been installed, so money has been spent. What is missing here? The proper knowledge of that, proper effort to make the right data of right installation made. This is another one of the big plant in Punjab. So what is happening here? So the ID fan is at the bottom, and it is connecting to this duct, and duct is opening in the stack. Similar thing. So everything has been installed here because it was easy to reach, easy to install, and they could have maintained. The problem is the entire duct was severing. Instead of one, they have installed 2 PM monitors, where there would have been problem. Both installed at one place. So both were giving the wrong data. See the idea of having the system, if one is not giving the right data, you install 2, but you are installed at the wrong place, so both are giving wrong data. And how did we figure it out? Emission was visible from the stack. It is a power plant. So of course it was 75 plus, and it was showing 15 and 20, which was obvious. The guy knew that this is wrong. So he couldn't prove that why there is a problem in the system. So this kind of installation problems were there. That is because of we didn't have enough information or knowledge or skill in that. I'm not talking only about the industry, but it's also about the vendors. He could have understood this and they could have guided it properly. Few more gems. So that is the stack I showed you about, that newly invented monitor, the wire one. That was a stack. So if you say there are multiple problems in that, 2 ducts are joining, just above that they have installed, so there is no 8D, 2D, 4D or 4D, there's nothing, they just install. Another plant nearby, we found that we asked them to show where you have installed, so none of their engineer were able to go on the site. He asked a laborer that can you go on the site. So if the laborer has to do that, they have to think about the same installation and maintenance. Nobody can do that. So it is a wastage of money if you do not do the right thing. And that stack analyzer will be on the ground, right? So there's an extractive system. So when we saw that where the data is coming, SO2, so he showed us the cabin. So this is cabin. There was no analyzer. There just a system, light was off. So he switched on the light, he switched on the fan. I said that is enough, we got the information. So this kind of installation is the only difference is when you have to install equipment which costs you 20 lakh, 30 lakh. This has been handed over in 8 lakh, 7 lakh, so which is for nothing. You are happy that you are giving the right data and you do not know if it is right or wrong, but this is how it is happening. Ultimately, it is affecting not only the plant, but also the entire idea of having SEMS in the system, which is not good for anyone. One of the big plant, really big plant, one of the India's largest steel plant. In the beginning, we had the first training program over here. If someone from MPCB remembers it. So we had been to the steel plant, we saw data of effluent quality. So pH was coming exactly 7. It was same for last 1 month. It was not changing, so everything was perfect. So we got a chance to figure out why it is so perfect, 7. So when we went on the ground to see that we saw all the equipments were dry. It was hanging in the water because there is no water going on. So the idea was that when we have the rain or we have extra water sometimes, or we eventually discharge some water, then it monitors. But monitors are required to keep in a right atmosphere. It has to be wet. It has to be in water. There is no water discharge, so it was dry, equipment was wrong, it was giving the right data that was monitored last time, maybe years back. So equipment was gone. They had installed the equipment right after ETP, so that was there. But this is additional installation. You think about the investment has been made for no reasons. And this data is going into the system, then it is giving everything wrong. So there's no purpose. One of the gems, this is about the installation, this is about the selection. That is the main problem. One of the vendors that we came across, some industry shared me that. So they shared that we have got a certified system from India. India doesn't have a certification system, and he got a certified. Who specially created the system for them? So we asked him to share the certificate. So we got these two gems. So who can understand? If you can figure out the equipment and all, keep it to yourself. Just tell me what is the wrong in the first one. So they said that this is equipment, certified equipment we have, and we have bought it from some of the vendor. What is wrong in the first certificate? So there is not that certificate has nothing to do with the equipment. That is a quality management system 9001. Think about the level can how an industry can be misguided. So the vendor sold the equipment by saying this is the certificate, we have a certified equipment. So and he got it. He didn't know, he couldn't differentiate. This is a quality management system. Now I hope that's not the situation right now. Another one, what we found is one of the vendor, technology provider, vendor, he got it tested in one of the lab. That is fine, tested, and it showed that we are performing near to what is required. And they said, I have got a certificate. But again, the thing is, certification system or getting it tested, test certificate or certification system is different. Certification system takes 6 months to 30 months to be done. How it is done? Every equipment is run through 6 months or 30 months in the field and in the laboratory, and then it is, and if there is some problem, it is repeated. It goes for 6 months to 30 months. It takes years. It takes millions of dollars to do that. It is the laboratory or the factory which is making this kind of equipment is also inspected to figure it out to ensure that this particular factory will make similar specification of equipment in the future of that batch at least. This ensures that one equipment which is certified when you are using, another equipment of that will also be quality. System works like we do in in India BIS does for fridge, etc. Right? Every equipment is not tested. So one is tested and get to know that there is a certified equipment, ISI mark equipment. But this equipment provider, they get it tested in the lab in 1 day, and then he said my equipment is certified. He got it written certified, which is illegal. That should not be written. Certificate should not be written over there, right? So this test says that for the particular point of time, for particular condition, temperature, pressure, gas flow, this data is okay. But it is not saying that it will continue to give you the similar result in another 10 days. It is not saying that it will give the similar kind of data if concentration changes. It is not saying anything. It is a random test of that particular point of time of the particular gas condition. So this is not certificate. So we need to understand the difference of that. Certificate comes like this, not one page. It is followed by 50 page or 500 page or like that. So longer the test has been done, what are the parameters, what are the result, how did you analyze, everything is supported behind that. And that is why these certified equipments are more costlier. So this is by MCERT, which is in UK. That is by TUV, I think it is Rhineland, in Germany. Some of the problems in the beginning had been related to data manipulation, which was in the first one, you might have seen it before. I mean, this level of data manipulation is not there in the system anymore, but might be possible, not a clean sheet, but there are some problems. In the beginning, what has happened, if you see in the first graph, what I'm showing here is, so a plant had a norm of 50 milligram per nanometer cube. So they had claimed on the top that it should not exceed 48. So every and 48 data, 48. So always comply. So that's why you see it, when it goes to the tip, it goes flat. So it is not increasing ever that. So sometimes it was being noticed why it is not going over 48. So I said, no problem, you take 43. So now 43. So we have been enough smart. So these are the challenges, these are the smartness that made us to think that our data acquisition system had been more smart. So that is why whatever the system we have, it is certainly far better than other countries that we have right now. So I'm not going to spend much of the time. You people have seen this. So there are some data gaps problem. If you see 15 minutes range or 1 minute range, you will figure out the data is not continuous. Some of the data we had found, and it's still happening, this is a little tricky to understand. If you see on the top, there is a 15 minutes average, there is 1 minute average, right? So 1 minute average data, when it is coming, and when you do it average for 15 minutes, what does it mean? The 15 data set of 1 minute will be averaged out, right? So the peak and the bottom will be different in 15 minutes, in 1 minute, right? Because it is averaging out in 15 minutes. If you see, both are same. It literally says it has cancelled the entire mathematics. So that was simulated or created, which will not be the case. And the bottom you see, some of engineer tried some of the brain. They said we have to show the variability. So they showed the variabilities. He didn't understand the difference between BOD and COD. So he crossed the BOD to COD. So COD is 250, right? No, 250 milligram, that is the standard. And BOD is 30 or 10. So to show the variability, he crossed the BOD far over the COD. So this can be identified only the person who understands that, right? For the environmental regulators or who has been into the system. Normally in the effluent industry, it will not happen like that. So these are the things. It is the real thing. It is not created. These were the actual sheets or actual screenshots. There are many like this. But to give you an idea, we had been from these problems. Now, most of the regulators across the state and industry understand these are the problems. And we have improved from that, but we should learn why the problem had happened, because we didn't know, we didn't have the enough idea, we didn't had skill, we didn't get enough trained or instructions on time. So these are the challenges I discussed in the beginning. New challenges has improved. We dealt with that. Most of I see the bigger corporates have managed to deal because they have the team, developed the team, got it trained, or through the consultant, they improved those minor situations which were superficial. Now the challenges have turned into little more in depth, because now you are moving towards the data quality, because data quality is one of the concerns still. We have a data quality which is very poor right now. Even now it is very poor. Why it is poor? The first thing is some of the system, some of the industry, we do not have the right point of installation. You do not have a stake where you can make a drill. You do not have enough length of duct where you can figure it out 4D, 4D, or 2D, 2D, or 5D, 5D, or the right position to installation. What you have to do some kind of test over there. And you have to find the right point, nearest to the right point where you can get representative sampling. It has to be tested, it has to be done. In calibration, what we do, we just do zero and span, right? That's what we do the calibration. Calibration is far more with that. If you see the guideline, it says you have to do a lot of tests. That is called calibration. Calibration during installation requires full calibration. There are many other things along that. Linearity, cycle test, repeatability, all those things has to be done. So we do not do. At least we have to do it during that point of time. Those non-certified equipments which has to go through performance test, right? Performance test, which is a USCPA based system, which calls about the RITA, cycle test, 7 days trip test, linearity test. Nobody is there to do that. There's no lab accredited to do that. Nobody is doing, the vendor cannot do this. So it literally means that what is required to be done to have that credible data, correct installation, you do not have the system. It literally means that the data you are getting, you have no confidence on that. So we need to have that. We need to learn, at least with this program, we should learn that what are these tests, why it is important, how it is being done. That is what the agenda of this program says about. Wrong measurement range is still in some of the plants. I'm talking about the big conglomerates. It's still in the big, many of the big plants I have seen, the measurement range is wrong. Intermediate server, still there are some vendors which are putting intermediate PC in between, which should not be the case. Non-standardized data, I will share some of the slides with you. Non-standardized data means our norm is milligram per normal meter cube. The data is dry. So when we get data from the monitor gives the data in ppm or milligram meter cube, right? We have to convert it to normal meter cube, normalize it to normal temperature and pressure, then oxygen and moisture correction, right? So when you corrected that, the data may multiply 2 or 3 times. You are already in non-compliance. I'll share you some of the slides. And you do not know. So many of the plants I have seen, they were very happy that we are far, far below than the norm. But they didn't know they are far, far ahead of the norm. So these are the corrections that we certainly need to make. We have to convert into dry because our flue gas has moisture. We have to have in 0% moisture. Then we have to standardize it for temperature and pressure. We have to correct it for oxygen or CO2, whatever we do, right? 10%, 6% O2 or 10% CO2. I'm just sharing one of the example here. We try to figure it out that SO2 in one of the plant we found, it was 120 ppm, a milligram meter cube it was being done. So the plant was pretty happy that my norm is 400 or 300, I'm pretty good. So when we tried to convert that, just figure it out, when we did it dry, 0% moisture, so it directly came into 403. When we did it standardized for the temperature, it became 587. When we did it at the bottom, at O2 correction we did, it became 530. So he was already non-compliant and that we're not aware. It is one of the big plant, very, very big credible plant. The thing is there was no idea in the system. They didn't figure it out. So these are the things we have to understand because your norm is standardized, milligram normal meter cube, that is what we have to see with the comparison to that. Right now it is not happening and not being focused, but tomorrow that is the future. That is how you have invested this much of money. If somebody is thinking we have invested 7,000-8,000 crores for nothing, that is wrong. Tomorrow suddenly the thing will come that we will have a compliance check system, then people will get lost, right? Where to go? So it's better learn on time, understand these problems and correct it. Leslie has already presented. So most of the plants, even I knew that most of the power plants, if I say, most of the power plants have installed the SIMs. I knew it, and I believe that certainly. But it was to the surprise when I collected the data for 2020-21, I found only 50% of the data, 50% of the plants sending the data for the entire year to the CPCB or SPCBs. The problem is, it is not like that knowingly. There are multiple problems. All those problems which we discussed before, equipment was not working properly, it was failed, the range was not fine, or equipment because it was not being maintained properly, they were not giving the data, it was out of service. All those things were behind this. Some of them might be smart enough that they know that there is a non-compliance, I'm not sending the data. But you know the guideline says you have to send the 85% data, right? So it is not strictly being followed right now, but I see that if you are going to 40%, 50%, after some time you get alarms and notices as well. They will do all the remote calibration, etc., or send you. You will get the email, etc. But large goal is 85% is required, and it is tomorrow, not today. Tomorrow it is going to be mandated for sure. So we have to correct those problems. It's not knowingly. It is certainly there are problems which is sometimes goes beyond hand if you do not know how to do that. So that was the situation. If you, Leslie has already shared, so we have the entire report. You can access from that, or you can search by the name itself from the Google. You can get that. So problems all around. You saw the gems in our installation in our country. So what we understand, how we summarize it is, first the important thing here is right equipment selection. We should have. If you have the right equipment selection, then we should also ensure that it should be quality assured. Either you select the certified ones and do the minimum test during installation, or when you have non-certified ones, you have to get it tested for performance. That is performance test which USCPA system says. That is as per the guideline. Correct installation is one of the biggest problem. It needs expertise for sure. You find it is a minor problem, but no, this is the major problem. 85% or 90% problem is from that incorrect installation. You can have high end of equipment of 40 lakh, 50 lakh, 60 lakh, but if you are not installing it properly, and after that if you are not operating and operate and maintain properly, you will not get the right data. Tamper-proof system, it has improved, that we are going enough smart in the sense of as far as data is concerned. It is not a big problem. Still, there are some problem in some of zones, I would say, but that is not a big problem. But regular operation and maintenance is the second one. So in this, correct installation is one of the biggest problems, the wrong data. Regular operation and maintenance which is missing, and you do not know how to do the regular operation and maintenance is one of the problem. So this is one of the biggest problems. So if we have this system, we will ensure the right data, quality data, and that is how we can move towards. to use it compliance check system. Right now we do not use this same data for the compliance check because it also needs some changes in the regulation. In Air Act, Water Act, EPA Act, we need to have those changes which will be used for compliance checks. We need those changes. But we do not have that changes as of now because we do not have the confidence in the data. We need to improve from here. We also need to set up the calibration certification system in India. We also need to have the accreditation of the lab which it does calibration, test and comparison with the standard reference method. All these are the part of the system to operate SAMs perfectly. So if we have all those systems, we'll have some changes in the regulations also in Air Act, Water Act and EPA, so that real-time data will also be used for compliance check. And that is how you will reach the system what US or Europe has, self-monitoring. One of the funny incident is some of the regulators, if we had gone to Swedish EPA in the training, Indian, we asked that how do you do the surprise testing, surprise inspection? We are common here in India. So they were surprised to hear that. They said, what is that surprise testing? So industry installs monitor, they send the data, and we are happy with that. Everything is fine. That will not be, aligned with our habit for sure. We will take time to do that, to be that much honest or have that honesty capsule. So these things are there. We need to move our own way. We have to ensure these things before we reach to that stage. But throughout this process, what we need, and I understand that one of the major problem here is capacity building. We need to learn from the standardized best practices, what we have in Europe, US, and we also need to learn from the mistakes they have made. We should not really repeat those mistakes again. So this is why this training program has been designed in such a way. The training program designed such a way. If you see in the agenda, the first day we are talking about the best practices. Best practices means in US, what is the certificate, what performance system we have, what are the tests is being done, how it is being done. European system, how the tests are carried, how the certification is being done. Second day we will learn mostly about operation and maintenance. So we'll learn a little bit about the technology, how you select the basic specification, how you set the tender, etc., and what should we focus when we put proposal for getting a new equipments, right equipments for your plant. But measure of that is how you operate and maintain it properly. So that part requires not the lecture as much, but your questions from your side. You have a problem, ask the problem to the speaker and the expert. They can certainly get you some answers. If you get the answers, if you get the solution, that is the best way of using that session. So do ask the questions, inquire all those. Third day we are going in the plant. We'll see the installation. Plant may be running or not, but we will see that how these equipments are installed, how these equipments work. We'll also have a person with us who will do with the manual monitoring equipment, because manual monitoring for PM or gas is also a standard reference method, where you compare with the data, right? So they will also show you that all these equipments. They will show you how the calculations are done, the easy way that you'll remember. And that we'll do all those things in the plant. And fourth day we will wrap up. We'll have the certificate part. We'll get your feedback. If you see the booklet you have, bag you have with you, apart from agenda, there is a sheet which is assessment sheet. So in the last day we need your assessment in that about the program, and your feedback in the bottom. And we also have some of the questions which you will cover during the sessions. These are easy, but covering all these sessions, you will be able to get the answer. So we need that back so that we feed into the system. This will automatically generate your certificate, and it will be sent to you in the print or directly. But that sheet is required. No sheet, no information, no certificate. Right? So that sheet is with you, but try to fill the fourth day, because by the time you will cover all the sessions and you will be able to score well. This is to the surprise that we did in Bhubaneswar. Many of the vendors got 60% score, which is pathetic. So you will be able to do it pretty well, I'm sure. So do listen, and we'll discuss those questions also. Do listen that, and I'm very much helpful that with the speakers, with the experts we have, we'll do pretty well. Take away from the program will be pretty good. We all will be happy with this. Thank you very much. बताइए सर, ऑडिबल हैं आप? That may not be required. We found a solution that everybody is not able to carry it. So what we'll do, that printed sheet, that is how it has been given. In that printed sheet, in the last day, if you see, there is a session on assessment. We will discuss all those questions. I will not give you the answer, but I will read out the questions a way that you will figure out that what does it mean. So we will go through the questions so that you understand the context of it. You give that tick, just a tick mark, and you hand over that sheet to us. Not required, because I found that everybody is not carrying. Yeah, right? Thank you. Any more question, please? So you are happy with the gems that I showed? Thank you very much. So the next session is going to be taken by, you know him already, uh, Mr. J.S. Kamyutra. He is an ex-member secretary CPCB. Beyond that, I would certainly would like to share the SAMS program that was started 2014 onwards. He was the person over there. So he was also the key person in developing the guidelines, guidance manual. Also in the training, wherever we have done, he has been the key part of it. So ask the question, most stupid question or most intelligent question. All are welcome. So he'll be happy to answer. Sir, over to you.
So good afternoon, everybody. And I hope that we have an interactive session. That will be better, right? Yeah. So I will pose some questions during the study presentation, and with the aim that you respond, so that none of us sleeps. And yeah. So the SAMS concept, basically, as Principal Secretary mentioned in the morning, that it relates to environmental policy of 2006. So environmental policy of 2006 refers to continuous monitoring. And the concept of continuous monitoring is not a new for the country. The first continuous ambient air quality system was installed in 1988. The first continuous water quality monitoring system was installed in 91-92. There were failures, there were challenges, yes, but we installed it that time. So now if you see, it is around 30 years when we had the first system, but we had different challenges as compared to the EU or USA. Our economy was closed at that time, getting things were difficult, custom duty was very high, technical ability was not there, IT was not that strong, so many challenges were there. So it took us a lot of time to develop the capacity and capability to come to this level what we are today. But the networking that we talk about, what Kanchan also mentioned, the first networking we did in 1995 1995, and all the data from continuous air quality monitoring system was coming to CPCB. All. We did not have the mobile at that time. The landline was very weak. Even the data from mobile monitoring van was coming to CPCB through mobile system. And at that time, the Airtel mobile was weighing half a kg. Bandwidth was very low. Challenges were there? Yes. We were doing remote calibration at that time. Just imagine what we talk now. So it is not that we could not do, we had done, but we had our own challenges. And when we started this policy of 2006, at that time it was felt that no, this is not the right time to go for continuous. But in 2014, when industrialization was taking place in a big way, the need to have more compliance, better compliance was felt now. Because considering the thinness of resources in the boards, it was found that it was not possible to monitor each and every industry, each and every stack round the clock. So what is the way forward to improve the performance? The way forward is IT. And that's the reason in 2014, March, it was felt, February 2014, it was felt that we should work on continuous emission or effluent quality monitoring system. We had started without making preparation, yes, but we started something. And as a result, today, we have few thousand installation, what Kanchan mentioned. I'll not go to the numbers. So, all the red category of industries are covered, the large one, the highly polluting. All the industries discharging into river Ganga are covered. All the common facilities are covered. All the common incinerators are covered. All the common STPs are covered. Everybody is linked now. So, besides, in spite of the gaps in the system, in calibration, in certification, in training, trained manpower, a better IT to manage the data, data validation, data plausibility, yes, we could link it. Now we have a linkage where we can improve it. And improvement can be done very fast now. We know the reason, we know the gap. We have learned by experience. And with this experience, we can improve. Just a feather, if you think, we started water quality monitoring online in 2014, and India is the only country which is doing it. EU has started now working on the documents. They have not done it, but we did it, and we have learned now. And that's the reason we have stations in river Ganges. We are putting river stations in other rivers. So we have success stories, we have failures also. We learned by both. Yeah. So this is the view, conceptual view that yes, we get the data from the monitoring station. It can be the manual, is continuous monitoring station on the air or SEMS. It goes through the data logger, and the signal is converted. It comes to the server, and then it is coming to all the boards and all this. So the reason why that we want a good system, why? Because for any good environmental governance, we need a good system for the betterment of the health of the people, for the betterment of the environment of the area, we need a good environmental governance. So for the good environmental governance, the most important is that we need to have good standards. Because we compare always the standards, a value which we compare. It may be ambient, it may be emission. We compare the standard. If we look into the ambient air quality standards, yes, we have standards. Some of them are stringent as compared to EU. Some may be relaxed. We have different environmental conditions. We have different meteorological conditions. Yes. And we may not be able to meet them. We have a different standard. Same hold good for emission quality also. We have standards for the emissions from the industry. And some of the standards are comparable with the EU or in the process of making at par with EU or USA. Some may be relaxed because we have our own technological challenges. Our unit size are very small. Just take an example of paper industry. We have most of the paper industry in India are 100 to 200 tons per day of production. But if we go to Europe, they have 2,000 tons per day. Can industry having 100 to 200 tons production meet that same technological aspects? No, we cannot close all the industries. It will take time by the time we come to the same at par with the other units, but we have our own challenges. These standards are governed by the raw material that we use, the technology that we use, the meteorological conditions that we have, and the fuel that we use. So we have our own challenges. We need to look into those challenges when we talk about framing emission standards. Once we have the standards, we need to standardize the monitoring methodology so that uniformity is there. Different procedure, different system that generate the data can be compared. If we are not able to compare it, we cannot draw any conclusion that what's the status of environment. So we need to bring all the data at par in terms of its quality, its reliability, its accuracy, its precision. Everything we need to bring at par. Otherwise, we cannot compare and we cannot formulate the policies. Because all this data is used for policy formulation. So if the data is not correct, if the data is not precise, any policy that we draw from that will lead to us erroneous solution. And that will not give the fruit what we thought that implementation of this policy will bring this environment. No, it will not bring. So that's why it's very important that yes. What public looks at, public looks always look at credible data. Because when we give any data or public sees any data, they believe it. They try to believe it, but up to a certain level. And the image, if you see, with the present scenario in the environment, everybody says, oh, pollution control boards are not doing anything, right? Because we have not been able to show them. We have not been able to develop confidence. That's the reason. That public always say, no, board to kuch nahi karta, board to industry ke saath hai. It may be true, it may not be true. But still, always the same statement is you find from the public. So we need to have a deterrent. We need to have good system, mechanism that the public develops confidence in us. And that can be brought through a system which has a transparency in the system. So that's next is transparency. That's why, because so many complaints come to you. In the board, every day so many complaints come. For the power plant people also, lot of complaints are filed against the industry. Because public believes that we are polluting. Because they see stack, oh, it's a black smoke. Immediately they feel it. But they are not aware what can be the reason for that. There can be reason, up, down, breakdowns, anything happening in the plant. Yes, it can. But public is not aware, and public has a perception that yes, industry does not do anything for pollution control, they are always pollute. And the board is in league with them, and they allow that to happen. So we need to develop a system where we bring transparency. Public develops faith, confidence, and they believe that what we say. And that can only be done if we have a dialogue between the public. Then we talk that yes, we have standards, we have mechanism to monitor, and strong regulatory framework is required. So you feel that the existing framework is not strong? Anybody want to reply? We have 3 laws, important laws: Water Act, Air Act, and Environmental Protection Act. Do you feel that the provisions in the Act are not adequate for abatement and control of pollution? Anybody want to reply? Everybody listen, yaar. सबको सुनने दीजिए, जोर से बोलिए. तो power है, power है. Then why this perception that we don't have strong regulatory regime? Why? ये क्यों आती है public को? Why public feels that we are not having that regulatory regime? We have. It's only implementation is weak. There are many causes for implementation. You may not have the right manpower. You may not have the adequate manpower. You may not have the trained manpower even. So many challenges are there, yes. But we have very good, strong regulatory regime where we can take action against any industry which is polluting anytime. You have section 33A, you have section 31A, you have section 5 of the Environmental Protection Act. You can take action against any industry, but the documentation has to be proper. All these sections say that you need to give a notice to the industry, but all these sections also say that in case of emergency, the industry can be closed down immediately. But the documentation has to be proper, and in absence of the documentation, we fail. We fail. And the industry keeps on polluting. So powers are there, but need to be properly used and documented properly. When the concept of SEMS was brought, the aim was, one, to bring transparency in the system. Second, to bring self-regulation. And self-regulation means it's not that the board has to go and tell the industry that you are polluting. The industry has to learn, see the data, find out, yes, he is polluting or not. And he has to give the same priority to the data that he is giving to his production. Because production is the top priority, and every morning the management wants to see the production data. The sales will also see the pollution data also, so that they know what they are doing. That was the aim when SEMS were introduced in the country. That was the aim behind that, to have that importance so that board does not want to go there. Because if industries of 25 million ton steel producing industry are coming with the Jindal, JSPL, JSW, even ArcelorMittal is going to 10 million tons. Can, with the limited manpower, we monitor them? No, it's not practically possible. So we need to have a system where we get the data, the industry gets the data, and they look into the data and become compliant. And then all this data, if they generate, and if they are meeting the norms, they can project their image in the market as a green industry. Their product will sell. Because when you go for, even for your stock market, you have to list risks. And if your industry has been given a notice, it will come in the list risk factor, so that your market goes down. So these are the factors. If you are a green industry, yes, you have your market scalability goes up. You can sell your product. I give an example of one industry. It was issued closer direction in 2010. All the product of the industry are exported outside the country, all the product. And now the industry was pressurizing that it be permitted to open. But if you see what I mentioned now, the direction, if you issue the direction, you have no power to withdraw the direction unless it is compliant. We may withdraw it on the pressure, but no. Law does not give you power to withdraw that unless it is complied with, or a suitable mechanism is put into place to achieve those. A time can be given, but not withdrawn. Directions cannot be withdrawn. So in that case, CPCB never withdrew the direction. And the industry was only apprehensive that if this matter comes into the newspaper, they will lose the market in US. So they paid the media to keep the information down. And they lost, during 2 months of closure, around 8,000 crores worth orders also. But still they could retain their image because they paid the media not to bring the information into the public domain. So that's why it's very important that you participate in the public domain. And if your information is disseminated to the public will have a confidence in you, yes. And they can see the data, they can visualize the data, and they can accept the data. So considering all this, in 2014, it was agreed that, yeah, all the red, highly polluting industries, all the industries which are discharging into river Ganges, all the common facilities, and subsequently, many of the red category of industries are also added in the list, which need to introduce SEMS or OCMS. Now this, as Kanchan already mentioned, this comprises of the sampling system, the analyzer, the data handling, the data acquisition, the data transfer, everything. Now it's the same what Kanchan mentioned, that was the challenge that they face in the data where the system need to be identified, so what is the system, where it is installed, calibration, acquisition, everything is coming. So I'll not go into detail in this. Yeah. So now OCMS or SEMS, whatever we may call them, it has certain advantages basically. It provides the data on the real-time basis. And once you get the real-time data basis, that means you know whether you are complying with the norm or non-complying with the norm. And in case you are not complying with the norm, you can immediately take the preventive action. That's the major advantage. And once you take the preventive action, you are optimizing your process control. In the present regime, what is happening? The board people the regulator goes to the industry, take a sample, gets it analyzed. It takes 15 days, 20 days, then you get the report, prepare a notice, give the notice to the industry. So, and after 2 months, the industry knows, oh, I have polluted and I've been given a show cause notice for closure. So that 2 months he has been polluting. And what is pollution? Pollution is your resource. Either it's in the form of energy, because when you talk about power plant, it's energy, or you have unburned coal or loss of energy, basically, which are the factors. And if we can control them immediately, yes, it helps us in optimizing the process control. The data is immediately available. As soon as the things happen, the data is available to you. So what we mentioned earlier also, the develop confidence in the public by data transparency. Then the important is continuous performance check of the air pollution control devices. We never do that. And that need to be brought into the consent regime, that all the pollution control devices, the performance monitoring of all the pollution control devices should be done at least once a year. It should be made a mandatory part, because in some of the environmental clearance conditions, this is a part. So this same should be reflected in the consent also to improve the performance of the system. Now we can have the time series analysis of the data also, that yes, how the system is behaving. And it also helps you in comparing two stacks, having the same capacity, having the same process, their performance, and improving the performance of the stack which is not giving you good result. So it helps you in that. And once you are able to achieve the standards compliance, your regulatory costs are going down. So when you say regulatory cost, we have two types of cost. One is the cost towards the air pollution control devices, their operation, their maintenance. Second is in terms of environmental compensation. That is the cost which is reduced if you are always meeting the norms. So it helps in reducing those costs, which we can, otherwise we could have been penalized and done. So once the industry is able to achieve the standards, improve the performance, it reduces the emissions, it helps the environment, it also helps in conservation of the resources, besides the impacts, reduction in the impacts. And then it can be used as a tool of emission trading scheme also, like which was initially tried in 3 states, Gujarat, Maharashtra and Tamil Nadu, that any industry which is having less pollution as compared to the standard, he can sell that difference to another industry which is having high pollution level. And now the same system is being pilot tested in Gujarat and may be implemented already. So we have, once we talk about the standard, that we should have standards, that is very important. So we have developed standards in terms of more than 110 standards for effluent and emission quality. And most of our standards that we have developed are concentration-based standards. That is milligram per normometer. But for some of the parameters, we have load-based standards. That means how much production is there, and per ton of production, what will be the emission. Common being sulfuric acid plant, 2 kg of SO2 per ton of sulfuric acid produced. Copper smelters, zinc smelters, coke oven plants, clinkers. We have some standards which are load-based standards, but most of the standards are concentration-based standards. That means they need to be achieved on 24/7 always. So this is something very different as compared to other countries. Most of the countries have load-based standards, but we have most of the time concentration-based standards. So we have developed standards for all the 17 categories of highly polluting industries. We have developed standards for common incinerators. We have developed standards for incinerators for basic drugs and such there. We have parameters like, generally the parameters are PM, SO2, NOx, common parameters, but there are specific parameters also. In case of alumina plants, we have fluoride as additional parameter. In case of an incinerator, we have HCl, we have TOC, we have dioxins, we have metals, we have furans, all these parameters, VOCs also as a parameters. So we have different parameters. And now when we have different parameters, the fuel is different in most of the cases. The process is different. The matrix of the emissions are varying. So now the question comes whether the same instrument is capable to monitor all the matrix. Some will be having high dust, some will be having high moisture. So whether it is adequate, or some gases like ammonia, HCl, chlorine, they are water soluble. So can we monitor with a normal method? So now the challenges are on the identification of the technologies. We have many technologies which can be used, but which technology to be used? We have different stack dias. In power plant, you have stack dia of 3 meter, 4 meter even. But you have small boilers, we have stack dia of 12 inch, 8 inch. Can we monitor the same system like ESP in the power plant, in the ESP in the boiler of 2 tons? No. So now the question comes, what is the pollution control device installed? That is another challenge. Once you install FGD, you have a lot of moisture. So now, if you don't have any heating system, whether we can use the same monitoring system to monitor FGD, emissions from FGD? No. So now the pollution control devices also control what is the technology to monitor. The stack dia, it controls the technology to monitor. The moisture content controls the technology. The matrix, yes. The moisture gases which are absorbed by moisture, yes. And the control technology. So besides this, there are many other things which also come into picture, which need to be considered when you identify the right technology. And that was one of the points what Kanchan also mentioned, that selection of the right technology, and which is done in CAL 1 when we talk about EU. They identify the technology for the matrix. But we don't have that. We are not in a process of certification presently, but trying to develop that. So it's a major challenge. So now CPCB in its guideline, which were framed by CPCB and revised in 2018, we have specified which are the parameters which need to be monitored, which is the technology which can be used. It tried to highlight based on the experience that we had. And the major question comes now, what to monitor and which parameter to monitor and which when to or stack to monitor. The question comes that. So in the consent, many of the stacks are consented as emissions. Many of the stacks are as vents. So vents are not prescribed or not identified for monitoring of emissions unless specified in the consent. But stacks which are consented, yes, they need to be monitored. Then the parameters for which SEMs are available, yes. Like if somebody wants dioxin and furans, no, we don't prefer. If somebody wants moisture, we try to avoid even moisture, but it is mandatory. So in those industries, in those units where the moisture level in the fuel is not varying, CPCB guidelines prescribe that the data collected by manual monitoring can be used. But in cases of incinerator, where fuel varies, moisture content varies, yes, we need to install that. CPCB guideline does not prescribe installation of mercury analyzer with all the power plants. But environmental clearance condition prescribe that. So if we have to have compliance of both environmental clearance condition as well as that. But CPCB is very clear that being cost prohibitive, yes, we don't need it. The reason being if somebody is installing FGD, it's most probably the emissions will be well within the limit because most of the mercury will be absorbed when we have scrubbing by lime. it will be within the limit. So CPCB in the guidelines never recommended that. Now we have various monitoring technologies we have now. So which to use, which is the right one, which can be used at the place to monitor, that's a major question now. So these are the various standards which have been framed for a number of industries we were talking about. And just for the information of, I like to just add something. So these are the standards for the power plants which were there. Initially the limit for NOx was 300, but it has been enhanced to 450 based on some study conducted by NTPC that Indian coal having high ash content and with the plant load factor being lower, not 100%, it is not possible to achieve the limit of 300, so it was made 450. So that's a major change which has happened. And yeah. Now we have boilers. This is a recent one. I'd just like to inform the. Initially, we have standards for the boiler based on the steam generation capacity, and we have only the standards for particulate matter, which were very, very high. If you see 1600 milligram, 1200 milligram, and 150 milligram. Now this revision has been proposed, which is in the public domain, and people, all of you can give your comments. So you see that we have made the standard very stringent. Less than 2 tons of steam generation, the standard is 500. We have brought from 1600 to 500. For 2 tons to 10 tons, it is 150 milligrams. From 1200 milligrams to 150 milligrams. So lot stringent has been brought into that. But this is a case for normal boilers. All the boilers which are used for producing power have to meet the norms of power plant which were notified in 2015. So that means any power plant, any boiler which is used for power plant and installed now has to meet the particulate matter emission norm of 30 milligram and not 50 milligram. So this is a major thing. We are trying to bring standards more and more stringent to bring at par with other countries. But it has to be gradually, it cannot be at one go. Yes. So this is there. Now when we talk about all this and we see that our standards refer to correction factor, what Kanchan made, 12% CO2 or 10% CO2 or 6% O2 or 3% O2 on dry basis. Yes. So that means all these values need to be corrected. And once we talk about correction, that means we need to monitor those parameters also. So we need to monitor O2, CO2 depending upon this. And wherever load-based standards have been prescribed, we need to monitor the flow also. Wherever load-based standards have been prescribed, we need to monitor flow. And wherever we are using dilution system to monitor the emissions, like systems based on chemiluminescence, system based on UV fluorescence, which are the same technology which is used to monitor ambient air quality. If those instruments are used to monitor the emissions from the stack, then we need to monitor the dilution factor also, so that we know that how much dilution is being done with a sample before it is sent to the analyzer to monitor that. This is another major thing that we need to look into that. And now this dilution factor varies from 150 to 200 times also. It's a large number. Moisture, yes, because we need to have dry weight. We need to monitor the moisture content. So moisture content need to be monitored where there is a possibility of continuous variation in the fuel quality or the moisture content. In that case, continuous moisture monitoring. But in systems where the fuel quality does not change, any data which has been collected prior through manual monitoring also can be used to do the dry weight calculation also. So this I'm not going, it's what already Kanchan mentioned. Now these are the parameters what Kanchan also showed. And now when we talk about the monitoring, we have monitoring, we can either do monitoring at the site, that is in situ, We can put the analyzer, we put the system in the stack, directly monitor it, and do the analysis. In that also, we have various types of technique where we can do that. And the second is extractive. We suck a sample from the stack, bring it down to the room where analyzers are kept, and do that. Now, when we take the sample down from the analyzer, conditions change. The temperature in the stack will be 140, 180, 100, 200. But when you take it out, the temperature changes. And there is a condensation taking place. Moisture will condense. And once the moisture condenses, many of the gases will be absorbed. So what we monitor will not be what is the actual what is coming out. So now what to do? That means we need to condition the sample also so that it comes in the same condition as we are having in the stack so that we can monitor it. So either we can use dilution system. Once we use a dilution, the moisture content gets diluted by 200 times. So that's a very, very low volume. Or we can bring it in the heated form, or we can have take out the moisture and bring the sample. So we need to find the ways, what is the mechanism, what we need to have to bring the sample so that the characteristics of the matrix does not change, because we need to monitor the precise data. So we have all these things, and there will be a lot of discussion, so I'm not going into each of these methods. So there are certain challenges now in the when we take a sample at the site or when we take extractive sample. So system is exposed to stack condition, because when you are putting in the stack, it is always having the stack conditions, high temperature of the stack will be hot, it will be having impact. Moisture and temperature interfere largely. Moisture monitoring is must for gaseous pollutants. Calibration is an issue, because once you have installed it, nobody will like to go up and calibrate the system, even for the gaseous. Leave aside the PM, which need to be done through isokinetic sampling. But even gaseous, nobody will go up and do the sampling. So that's a major challenge. And maintenance. Because everybody thinks data is coming, okay, fine, that's without calibration, without. So this is a major challenge, yes, but in most of the stack, in situ has been installed. Then it is also impacted because if you are using the light source for particular monitor in situ, it is also impacted by the vibration of the stack. The alignment of the optical changes, and once the alignment changes, the reading changes. So these are some of the challenges which you face when we do it. But you have certain advantages. There is no transfer of sample. Conditions remain same. There is no housing is required. You are not required to bring the sample down. You are not required to have any hot pipe heating system where you consume energy, or cold system where you take out the moisture. You don't need anything. Cost is less. And most of PMCMs are in situ type. But when we talk about extractive sampling, that means we are sucking the sample from the site. It needs to be drawn from the stack isokinetically now. And isokinetically means it needs to meet the criteria of 2D and HD, that the sampling point has to be at a distance of 8D from the bottom of any interference and 2D from the top minimum. And that is the area what Kanchan also mentioned, installation is wrong, and especially in the power plants, most of them are installed in the duct. Because at that time, there was no thought about installing SEMS, and even monitoring was conducted in duct at many of the power plants earlier also. So in such cases, what to do? How we get now true value? Isokinetic sampling. Unless we do isokinetic sampling, the results may not be appropriate. So we need to do certain studies to identify or find a factor that by which, if I am monitoring at this place, what is the factor or the percentage I am getting in terms of that reading, actually, how it is representing. So we call this as a stratification study. It needs to be done using any inert gas. And we monitor the inert gas. We know we inject a gas with known concentration try to monitor at that point and then find out that what is the concentration that I'm getting, because it is diluted with the stack gases coming out. And then I try to develop a factor. And with that factor, I try to correlate, yeah, this is the value actually which I am getting instead of this. That is in the worst case scenario where I don't have any possibility to install at the place where I meet the criteria of 8D and 2D. That's the criteria. And then for all these systems, so when we talk about the optical systems and all this, we need to have a dust factor calculation. So dust factor basically, as per the guidelines, need to be calculated at different plant loads, 50%, 75%, 100%. And that is practically not possible in an operating plant. And that can only be done when the plant is either in the stage of shutdown for the preventive maintenance or in the stage of starting commissioning at that time. So in that case, if we can't do it, then we need to do 15, 18, 21 samples at least to find out how the system is behaving, how I'm getting the value. And when I draw the curve, I get a curve which can give me a representative data. And because this curve will be used for calculating or comparing with the light transmission or light absorbance now. So unless I get a correct picture of this, I will not able to do this. And this will again vary from your fuel quality, color of the coal, lignite, anthracite, what you are using, it will depend upon that. You need to monitor for every fuel that yes, these factors need to be monitored. Then distance from source and analyzer becomes very big when we are having extractive sampling. And there will be a number of biases which may come in the monitoring of secondary particulate matter also. But it has the advantage that we can monitor the wedge sacks. Measurement ranges of the analyzer may be maximized. Size fractionalization is possible. And maintenance is less as compared to in situ. Now for particulate matter, we have so many technologies, there may be more, but these are some of the technologies which CPCB did a comparative study. Find out that the selection of the technology will vary based on the stack velocity, based on the dust concentration, based on stack dia, based on the pollution control devices installed. So based on that, certain matrices of the technology has been done. Now if we see the first two, DC tribo and AC tribo, you see the difference now. DC tribo is giving the data in grams per second, whereas all other are giving in milligram per nanometer, right? So there the time is coming, here the flow is coming. So that means we need to monitor the flow also. So that is additional parameter we need to monitor with that. Second one, if you see the AC tribo, it gives both, but it works on electric charge. And now if you are having an ESP prior to that, you cannot put that system now, because ESP is also based on electric charge and this is also based on. So need to put a system which neutralizes the charge of the ESP then. So another device has to come into bin before you do that. So same system cannot be used everywhere, even if you want to use it. So this we need to learn, that right selection of the system or technology is very important when we try to monitor that. Now we have these so many technologies like chemiluminescence, UV fluorescence, IR correlation, FTIR, DOAS, FID, TLD, and all these technologies are there. But they have their own limitations. They have their own advantages. Like in case of chemiluminescence and UV fluorescence, we need to have the dilution. In case of IR, we can monitor at a higher concentration. But when we use the FTIR, if you are monitoring multiple gases, yeah, it is economical. But when you are using only one gas or two gas, this is not economical. But it has the advantage that it can monitor many of the gases which are even water soluble. Yeah, but the cost prohibitive, it is cost prohibitive. Then you have the DOAS, it can monitor most of the gases which work in the IR range, most of the gases. FID is for this, TLD is there, which also monitors many of the gases. But which gas you not want to monitor, how many gases you want to monitor, what is the matrix we want to monitor, and that will govern the technology that we want to use.
Sir, previous slide, sir. Previous one. Previous slide.
Previous?
Yeah. In the AC, that turboelectric type of that SPM monitoring, is there any criteria of probe length? What the probe length we are going to install in 4 meter of diameter?
It's distorting.
Hello?
Yeah,
Yes, sir. Now voice is clear, sir?
yeah, it's better.
Sir, in turboelectric, actually there is the probe in turboelectric. So what is the criteria of problem? Because we are in fourth column, the duct, if it's more than 1 to 4 meter diameter,
Duct diameter.
yeah, there we will install the AC turboelectric for SPM monitoring. So what is the probe length? Is there any criteria of probe length?
It's based on the criteria of the probe length only.
Because the probe length,
You can extend it also.
yeah.
People do that. But this is all based on the actual data that has been collected from all the vendors. And this exercise has taken 6 months to 1 year roughly.
No diameter, but actually in chimney there is the turbulence. At flue gas is turbulence there. If we install 1 meter of probe length, so there may be some the reading error.
If I rightly got your question,
My question is that,
in the stack you had turbulence.
yeah,
Okay. But,
what is the probe length of turboelectric? Yeah.
but there is no board, otherwise I could have explained to you. Okay. In hydraulics, okay, if this is your stack, right? There will be friction at the bottom and both the sides. The flow will be like this. So that's why we monitor at number of points in the isokinetic. That's the reason. And if you want more clarification, we can discuss it in the lunchtime also. I can explain to you.
Because earlier, when I just go to the one training program, there we have consultant so that if there is less than 1.5 meter or 2 meter of duct size, then we have to go
Yeah.
for the turboelectric.
The
Otherwise,
problem is when you have the duct with 4 meter diameter, that means your just then you listen. Generally it goes to the board. Sampling probe is not there, which can monitor up to 2 meter even. Okay? That's the major challenge with all the boards. Nearly all the boards have the same problem. And Ronald would like to add something.
I think what you're asking is, you said tribo, but you actually mean electrodynamic. So the AC version. Now the AC version has the advantage that it is far less flow dependent, and that it has shown also in QL certifications in Europe that if there is a significant distance between the last blade of the ESP, and significant means about 6 to 8 D of stack or duct diameter, then there is, or if there is an ID fan, for example, built in between outlet of the ESP and the position of the probe, of the electrodynamic probe, then there is no interference of the electrostatic charge from the particles coming from the ESP. And you have to have anyhow at least 8 times the distance before the position of the tapping point of your probe or your dust monitor. So you always have that distance, and therefore even with ESP built in, there is no interference if the positioning is correct. And probe length can be 2 meters, 3 meters, up to 4 meters, I have seen in the industry. And at this position, we are also in a place where we have a laminar flow. That means laminar flow means relatively very equal distribution of the particles through the stack. And therefore, even if you have, let's say, a 5 or 6 meter stack and you have only a 2 meter probe length, it will give you a representative data.
It will give representative, but it will not meet your norm criteria of sampling points. That is another point. Because sampling point criteria is also defined. That how many sampling points has to be there based on
Yeah,
the diameter.
but that is okay. That is the calibration part.
No, even for that, otherwise also, that is very clearly defined in our legislation. That this is the diameter, what number of sampling points has to be there.
Okay. Yes.
Traverse point.
Yes. Yes. Traverse point. Yeah, but that goes for any non cross stack instrumentation. Yes.
Most of the, that's the major problem we are facing here. Most of the boards don't have a sampling flow with more than 2 meter diameter. To cover stack more than 3 meter diameter. That's the major challenge here. Always. Breaking, it's 4 meter, 5 meter. That's it. It's clear?
One dispute is there. Actually, earlier, what we saw in the notification that if the die is more than 2 meter or 2.5 meter, we have to go to the opacity meter. Because as per our government guideline, our certificate. Yeah. But if there is less than 2.5 meter, we have to go opacity meter or AC
So I come to that.
because there is the probe length issue. If the probe length is 1 to 1.5 meter, then it will give the correct reading. And if the dia is high and our probe length is nearby 1 meter, there is some turbulence issue, so reading may be effect. So accuracy of reading issue is there. So that's why some guideline actually earlier
This is based on the actual data. What is their problem? Based on actual data. They may not be giving you, but when we prepared this matrix, it was based on the information that we collected from each vendor and analyzed it, and it took around 6 to 8 months to prepare this matrix. Because we have taken another point that you raised, opacity monitor. Now this challenge will come because when we are talking about FGD installation or we are talking about bag house with PTFE filter, where the emissions will be around 510 milligram. So this problem will come whether we need a single path or a multiple path. So, you like to add something?
But after the wet FGD, you can't use opacity monitor anyhow, not at all, because it measures your water and gives you wonderful water signal.
That's what I'm saying. And in FGD, what they are doing now, they are putting a heating system, so that thrust is given, the stack it goes out. So there are number of challenges which are coming. So this is another challenge is that whether the existing systems installed, whether need to be replaced. Because when we are talking about PTFE filter, the values are 5 and 10. So these are the challenges, and with FGD coming up, this is another challenge will be there. So that's why, sir, right selection of the technology and what we need to look into is very important. So now there are certain questions which always come when anybody wants to monitor that what should we monitor, which vent should we monitor, what are the parameters to be monitored. So first thing is only those vents or stack which are consented, for which limits have been prescribed. Only those parameters for which CPCB has specified in the guidelines that yes, SEMs are available. If SEMs are not available, you cannot do that. But there may be limit imposed by CPCB, but there are states have the power to impose certain additional limit also. If they impose additional parameter, and if SEMS is available for that, yes, then they will have to install that SEMS also. Then whether we need to monitor flow and velocity every time, we need to monitor, yes, where load-based standards are there, and where DC tribo is installed. We need to monitor that. Stack temperature, yes. Why? Because we need to convert NTP. Not moisture monitoring device is necessary at all stacks? No. It is clearly says except for the cases where moisture in the fuel is varying, only in those stacks, otherwise no, because considering the high cost of the system. But it is mandatory for hot wet extractive system. If you have the hot wet extractive system for sampling, yes, it's mandatory for that. Now then the question is how to calibrate PM sense. It is only through isokinetic you can calibrate. Is it required to do it at different load condition? Yes, ideally. What I mentioned, it needs to be calibrated at 3 different loads. But that is ideal, but it's not possible. How to vary the load? So that's also we discussed that yes, in a running industry, it's not possible to vary the load. Yes, but that. How many samples are required for PM sense calibration? For the dust factor, what we mentioned with the varying load, at least 9. 9 at 3 load conditions. But since we are not able to do that, we need to have more samples so that we come to that. And then what is the frequency of calibration required? Whenever there is a drift of more than 20% expected, then yes, we need to recalibrate the dust factor so that we get the values. Then the question comes, who will calibrate? What is zero calibration? What is span calibration? What is the frequency? So only those laboratories which are accredited under the Environmental Protection Act should be allowed, or as per the guidelines, are permitted to calibrate, but we need to empanel those laboratories, which we will talk in the evening when we talk about calibration aspects. What is zero calibration? It's just to see whether the zero drift is there or zero has changed, then we need to adjust the zero. If the zero adjustment is there, then that means we need to the span adjustment also, because that will also change. And then what is the frequency? Then the guidelines say that yes, zero should be seen on the daily basis, and the span, etc., whenever it is required, or at least once a week span need to be calibrated. So that's as per the guidelines. Then the other important points are what is the instrument range, what is the calibration range, what is the selection range, because that's very important. If the instrument range is not there, all the values will be flat. So what was shown in the curve, yeah, all the values will be flat. And then when we try to calibrate the system, the concentration of the gas should range between 75 to 80% of the range of the instrument. And the range of the instrument should be around 2.5 to 3 times the standards basically. If you have a standard of 30 or 50, so at least 125 to 150 should be the range, so that you don't get a straight line as soon as the value is reaching the standards. Now, is it required to calibrate the whole system? Yes, because when we are talking about sampling by the dilution method, we are talking sampling with the hot wet extractive method, or we are taking out the moisture. That means the conditions are changing, and that means the entire system need to be calibrated along with the analyzer. That's very important. So now we have the data acquisition system where the data is coming, and it should come as per the guideline directly from the analyzer. But most of the people have put IoT in between, and the data is coming through IoT, and the person who has installed IoT is also having the responsibility of transmitting the data. So the source code is with the person, the transmission is with the difference, and that's the point where management or manipulation or can be done, right? This is the same thing. So this is how the data is coming. So the general challenges are that what parameters to be monitored, which analyzer principles are approved, what should be the analyzer range, which this we all discussed just now, will not repeat it. Now when we get the data, we get in a different form, and what Sanjeev also showed you some graphs where the value was constant, where the values were. But those issues can be tackled. It's not that those issues cannot be tackled. We can have a better software that if any value which is stable for continuously 15 minutes, 4 values or 5 values are stable, immediately alert can be given. If the values drift suddenly and keep on, yes, alert can be given. Because spike, the value when they increase, they can increase very fast, but when they try to come down back, they will come slowly. It cannot be rapidly. So if such features are inbuilt in the software, so half of the things can be easily identified, that where the things have gone wrong and what need to be done. Then interrelation between the parameters is very important. Like SO2, we take one parameter, for example, SO2. If SO2 changes, it's not that NO2 will also not change. Because if the temperature is not changing, NOx cannot change. If the excess air is not changing, NOx cannot change. But still if it changes, then something is there. So if we have some such safeguards in the software, we can easily identify that what's happening in the system. And this can be done directly by the IT itself. So these are some of the things because I got a signal that already I'm past the time. So if we have any question, we can discuss it. So I like to close it here. These are the aspects on the calibration side, which we'll look in the evening also. We have a session on calibration. We'll do that at that time. So I'll try to close it because I got a signal 2 or 3 times that I'm past the time. Yeah. So thank you, everybody. Thank you very much. If there's any question, we can discuss it.
Yes. So we can break for the lunch. So we can break for the lunch. You unfortunately have only 14 minutes left. So utilize your 14 minutes if you want to discuss something during lunch. You have no problem. Please, lunch is very important.
facilities such as power plants and other sources that may fall into that category. So we have very prescriptive quality assurance and control tests for SIMs within the United States. That also includes data reporting. So we'll go over some of that today. So quality assurance and control plan, Part 75, Appendix B, establishes the types of ongoing QA tests, quality assurance, that we are required for SIMs. The frequency of each type of test and the performance criteria are specified. First off, we have daily calibrations. That's zero and span. We have linearities, which are performed on a quarterly basis. And we have a relative accuracy test audit. These are three of the pieces to the quality assurance puzzle. We have data validation procedures, which are also specified under this part. Grace provisions are provided. So based on your operation of your unit, you can get a certain amount of grace period. So if you haven't operated in say, the first quarter of the year, and that's defined by a minimum number of 168 hours. So if you haven't operated 168 hours in a quarter, then you are allowed to postpone the testing. So you can postpone for up to 720 unit operating hours for RADAs and up to 168 unit or stack operating hours for linearity checks. You have 8 clock hours for daily calibrations after startup commences. That is a startup grace period. So you do not have to start a calibration when you are in the startup of the unit itself. Part 75, Appendix B, includes the requirements to create a written QA/QC plan. So in that QA/QC plan, amongst other things, shows your system, the type of instruments, your declared range, maximum expected concentrations, and some other key components. And this document is submitted electronically, not only to the regulatory agency within your own state, but also to the EPA. The facility must maintain a written record of certification and QA test procedures, maintenance activities, and corrective actions. These are included in that QA/QC plan, and they declare how you will handle certain situations in case you have instrumentation failure or failed QA tests. The QA/QC plan is a living document, and that is updated as necessary. So the frequency of QA/QC tests, with the exception of QA tests conducted during conditional data periods, QA tests validate Part 75 emissions data prospectively. That means going forward. Hourly data collected during a grace period are considered valid until the grace period test is attempted. Then, if the test is failed, the data are invalidated prospectively. QA tests conducted during a grace period do not eliminate or reduce the requirement to conduct additional QA tests. For instance, when a linearity test is done in a grace period, if the quarter in which the grace period test is completed, if that is a QA quarter, in other words, the unit has run 168 operating hours, the grace period test does not satisfy the linearity test requirement for that quarter. A second test is required in that quarter. I know it sounds a little strange, but that's what you have to do. You have to do 2 tests in 1 quarter if you couldn't get it done in the quarter previously. Daily calibration checks and interference checks, which are only for flow monitors, are conducted once every operating day, except where a monitor has been qualified to be used offline or to use offline calibrations to validate data on a limited basis. So what this means is that under Part 75, you do not have to conduct a calibration when the unit is actually offline. You can perform a specific test to demonstrate that you can do a calibration during offline periods. but typically Part 75 requires that you are in an online condition and you running at some sort, having combustion in the boiler or the unit. So for a linearity check, you conduct those once every QA operating quarter, unless again you have a non-operating quarter. The maximum interval between tests is 4 calendar quarters plus a grace period. So that's actually 5 quarters. So you can go 1 year and then have 1 additional quarter after that. Gas ratas. So relative accuracy test audits are one of the primary ways that we challenge our SEMs. Our SEMs are not assumed to be in compliance once they're installed. They are assumed to be out of compliance until they are certified. So gas ratas are part of that piece, and once every 2 to 4 operating quarters, depending on the result from the previous test, you can get a reduced frequency. So you have 2 quality assured quarters, or potentially 2 quarters in a row to be required to test. So that's every 6 months roughly. If you're between 7.6 to 10% of the reference method value. And you have 4 quarters if you are below 7.5%. Some alternative relative accuracy specifications are available for low emitters. And quality assured operating quarter means a calendar quarter in which there are at least 168 unit or stack operating hours. The maximum interval between successive ratas is 8 calendar quarters plus a grace period. So there again, that means you can go up to 2 years and 1 quarter. But that is typically reserved for units that are peaking units. There's combustion turbines in the United States where they do not operate except upon demand, and so they may not be available. QA/QC test performance specifications. Part 75, Appendix A, includes the procedures for conducting ratas, linearity checks, 7-day calibration error tests, and cycle time tests. The specifications for the types of tests required for initial certification and recertification are in 75.2. Note that data acquisition and handling system verification requirements are part of the certification process and are also located in Part 75. Section 3 of Appendix A provides the performance specifications that must be met for each type of SEM certification or recertification test. We have alternative specifications. There are alternative specifications for QA/QC tests such as daily calibrations, linearity checks, and ratas for low emitters. So a low emitter is defined as a unit that emits less than 0.2 pound per million BTU or 86 nanogram per joule. And the relative accuracy is less than 10%. The rata can still be passed if the difference between the mean of the reference and the mean of the SEMS value is less than 0.02 pound per million BTU or 8.6 nanograms per joule, and qualify for annual testing if the difference is less than 0.015 pound per million BTU and 6.45 nanograms per joule. So if you are using FGD or some sort of control device that reduces your emissions below those thresholds, you get an incentive for being able to use a reduced frequency. There are some certification and QA test exemptions. Linearity checks are not required for SO2 and NOx bands that are actually below 30 ppm. For dual range monitors, linearity checks are not required on a range that is not used during the quarter. So in the United States, if we have FGD or we have low emission controls, what that means is we will typically run dual range instruments. We will have a normal operating range, which is the lower range, and we will have a high range on that same instrument that will allow for us to capture unit or measurements during startup and shutdown and points where we might be emitting above our normal operated control status. SO2 radas are not required for units that combust only very low sulfur fuels, such as natural gas. So now I'm going to get into some test specifics. So we have a cycle time test. The cycle time test is one of the certification test requirements for gas monitors. Zero and upscale calibration gases are injected to determine the upscale and downscale cycle or response time, starting with a stable stack gas. So the unit has to be online when you're conducting this test. This is not an offline test, and this runs all the way through to the probe tip and back. Starting with a stable stat gas concentration, zero gas is injected, and the time it takes for a 95% of the step change between the stat gas and zero gas concentrations to be achieved is the downscale cycle time. So when you go from 100 down to 5 ppm, 100 ppm to 5 ppm, the amount of time it takes for you to go from stable to stable is your cycle time. The cycle time test must not exceed 15 minutes. Now that seems like an extraordinarily long period of time, but the reality is we primarily use for coal-fired stations or extractive dilution type systems, and we have long runs of sample line. So really 15 minutes seems like a long time, but it can take 15 minutes to get there because you're not having necessarily the same amount of volume that you would get through a extractive dry system or even an in situ type analyzer where you would have almost an instantaneous response. The 7-day calibration test. So this is also required. The manual and automatic adjustments are not allowed after a zero and an upscale injections are made each day. So the challenge of this is to show that the instrument is within a tighter criteria than a normal daily calibration for 7 days in a row. And it is largely hands-off. You can make adjustments after the calibration has been completed, but it still has to be passing. So the calibration error limit for the 7-day drift test is 2.5% of the span for SO2 and NOx monitors and 0.5% of your diluent, and 3% of the span for your flow monitor. These are twice as stringent as the daily calibration error limits, which are 5% of span for SO2 and NOx monitors and 1.0% of your diluent gas monitor, and 6% for flow monitors. So the linearity check, as I mentioned previously, is done on a quarterly basis most often. It involves 3 calibration gases: a low gas, a mid gas, and a high gas. You also have to conduct 3 separate tests during this period. So this could take you, depending on the response time of your system, could take you, 4 hours or even more. The test is conducted through the entire sampling system, including the filters, scrubbers, conditioners, and as much of the sampling probe as practical. So we don't incorporate any ball valve or anything at the top of the probe that would reroute the gas through the sample line. This has to be done as it would sample stat gas. From Appendix A, Section 55.2, the definitions of low, mid, and high gases are 20 to 30% of your span, 50 to 60 for mid gas, and for your high gas, it's 80 to 100%. It's important to note that the same gas may not be injected twice in succession. So the example here of low, mid, high, and then high, mid, low, and then low, mid, high would not be acceptable. You can go in either direction, but you cannot repeat it twice. Otherwise, it will be an invalid test, and your SIMs will be out of compliance. The unit must be combusting fuel during the test and must be operating at conditions of typical stack temperature and pressure. This is so we don't have any interference or any anomalies generated by the fact that maybe the dilution probe is not, or the orifice is not up to operating temperature, or other anomalies that could affect your sampling system. It is also important to note that this does not mean, in the case of a power generation facility, that you need to be generating electricity. You just need to be online as far as the unit's concerned and combusting fuel. And if you have normal operation as far as temperatures in the stack. So the linearity acceptance criteria. NOx and SO2, the error shall not exceed or deviate from the reference value by more than 5%. And that's not a span value, that's the reference value on the bottle. The results are also acceptable if the absolute value of the difference between the average of the monitor response values and the average of the reference value is less than or equal to 5 ppm. For diluent, O2 or CO2, the error shall not exceed or deviate from the reference value by more than 5%. The results are also acceptable if the absolute value of the difference between the average of the monitor response values and the average of the reference values is less than or equal to 0.5% O2 or CO2, whichever is less restrictive. So this is just an example of where we ideally want to fall within a linearity. You can see the 5% upper band and lower band. If we're outside of those, then you have a failed linearity. You have to take corrective action, at which time then you have to redo another calibration and then redo your linearity check. The relative accuracy test audit. The ARADA is a set of simultaneous measurements made by a SEM system and a reference method or methods in order to determine the relative accuracy of the SEMs. So what this means in the United States is we typically have a test team that comes out to conduct a RADA test. They will bring out a mobile laboratory. It will have the instruments in there for whatever constituents are required, whether it's NOx, SO2, O2, CO2. You will run sample lines up to that test location. They will set up a probe, insert the probe, and they will begin doing calibrations, and they will do a comparative test between their reference method and your SEMs. And when I say reference method, what that means is if the station SEMS is behaving erratically or is not consistent, that is typically the point of failure. So the reference method kind of trumps your SEMs. The RA, the relative accuracy, or RA, is calculated using equation A10 in Appendix A. The parameters are used in the calculation include average SEMS value, average reference method value, mean difference between the SEMS and the reference method values, and the confidence coefficient. So each RADA must consist of a minimum of 9 runs. It may consist of more than 9 runs, however, a maximum of 3 runs may be discarded. For example, if you do 12 RADA runs, you can throw away 3 of those runs, but you still have to have 9 valid runs. If you were to do more than 12 runs, you can still only throw away 3 runs, and you have to include all of the other runs. Each run of a gas or moisture monitoring system RADA must be at least 21 minutes in duration. And and this is pretty typical, 21 minutes or more, depending on the response time of the instrument. Typically in the US, what we like to do is we have to do a response time for the reference method system. So we inject the gas just like you do with your regular SEMS, and we get the amount of response time. And what we will do is operate in a number that is at least twice the response time per point in a traverse point, which I'll get to in a minute. But it is important to make sure that we don't just arbitrarily just set it up. There are some steps to this. So you must perform errata while firing the primary fuel for the unit. So if it's a coal-fired unit, you're not going to burn, and you can start up on fuel oil. You can't do the test on fuel oil only. For dual range analyzers, you perform the gas rata on the range normally used for measuring the emissions. In most cases, this will be the low range. Gas ratas shall be conducted at the normal load level, low, mid, or high, as identified in the electronic monitoring plan. This electronic monitoring plan is part of your QA/QC plan, but that is updated on an annual basis. So prior to going and conducting the test, the station will have to look back for 12 months and see what their normal operating band was, which is divided into 3. You can have 2 load levels designated as normal load. If so, you can perform the test at either load level. Usually the situation that comes into play, I'll show you here in a minute, but it can be a little bit different than what you might think it would be. So if you look here, the upper shows high load, megawatts, 343 through 473 megawatts. And you've got 5,000 operating hours there, so 77% of that year, or the previous year, was conducted, or we declared that as normal load, because that's predominant. We could use one of the lower loads, the 11.5%, as a second normal if needed. But based on that operation, we would say that the high load is the normal load. If you go down to the lower chart here, you can see that the low and high loads are actually very close to each other. So what this does is this actually allows you to test at one or the other, whichever is better for dispatch, because you have money involved with generation, so we want to be able to put it wherever dispatch can put the unit. So one of the first steps, in addition to determining your response time, is a stratification test. Once the tester has all of his instruments calibrated, you have to conduct a stratification test to determine what your sampling scheme will be. Stratification tests consist of a minimum of 6 points on each axis, 12 points total, using US EPA Method 1 criteria. So you can see the grid up at the top, which is each axis, or if you have a rectangular stack or duct, then you would have to use more points in a grid configuration. An alternate 3-point traverse according to Part 60, which is where we have performance specifications for instruments. Performance specification 2 does allow you to use a long traverse. However, this can be problematic on stacks that get over a certain length, because you have to test at 16.7, 50%, and 83.7. So if you only had one port available, one test load port available, you could do this in the US. You still have to do the stratification test. The problem is you're going to be limited by how long your probe can be, because at a certain point it's going to sag, and then you're going to run into sampling issues there, because you're not getting a representative sample on the same plane. This is very important. The unit load must remain constant, plus or minus 3%, whatever that is. Whether you're doing that as a steam rate or a power generation in megawatts or whatever load, however you determine load, it must be consistent, so you minimize any sort of cycling of your emissions, your target pollutants. The amount of stratification for each pollutant and diluent present at the test elevation determines the number of sampling points for the reference method. So it's acceptable to use a 3-point traverse based on performance specification 2 if you are plus or minus 10% from the average concentration for the traverse points, or if no single point is plus or minus greater than plus or minus 5 ppm of the pollutant, or 0.5% O2 or CO2 from the average. It is acceptable to use a single point traverse, which means you can go in and you put it at one fixed point, at least a meter in. If you are less than 5% from the average concentration for all traverse points, or if no single point is greater than plus or minus 3 ppm absolute for the pollutant, or plus or minus 0.3% of your diluent from the average. So this, in certain cases, the more laminar your flow, the better mixing you have, the better opportunity you have just to do a single point and not have to do multiple points during your RADA. And what that would set you up for is you could run for 21 minutes and be done with each test run. If you have to run for greater than twice your response time, if you have a 10-minute response time and you have to do a traverse, then you have 20-minute dwell time at each point, and so you could go up to an hour for a RADA test for one run, and you have to do a minimum of 9. The other part of what the other function that a RADA serves is to determine whether or not you have any system bias. So as part of the calculations, we determine a bias adjustment factor. So the bias adjustment is the amount of systemic error or systematic error of a system. The statistical analysis of RADA reference method and the SEMS test data to determine whether the SEMS measurements are biased low with respect to the reference method. The bias test is required for each SO2 monitor, NOx monitoring system, and flow monitor. If a bias test is failed, Part 75 requires a bias adjustment factor to be applied to each hour of subsequent SEMS data. So 1 hour past the completion of a RADA, you start applying this bias adjustment factor. Bias adjustment factors are not required for CO2, O2, or moisture monitors. So as you can see in this table, you have your reference method in pound per million BTU. You have your SEMS emissions rate in pound per million BTU. The reference method is reading 0.001 higher in pound per million BTU. That's a 1.3% bias factor that's applied. So that will push your numbers up to match those of what they should be based on what the reference method saw. Here you see just the opposite. The SEM system is reading higher than the reference method. So therefore no bias adjustment factor is applied, and it's left alone at 1.0, so that's your multiplier. Sources of bias, this can be many things. Sources of bias can be probe effects, plugging, scrubbing. If the probe isn't heated properly, you can get water droplets. If it's a dilution probe, you can have temperature issues, you can have pressure and gas density issues, you can have contaminated dilution air. As you'll learn tomorrow, a dilution probe uses dilution air as a motive force. So if you have contaminated air, it will affect your sample. You can have water entrainment in your sample line, so if you're using a dry extractive system or any sort of extractive SEMS, and you get water into your lines, that will impact how, especially the water-soluble stuff such as SO2. You can have leaks. You can have leaks at sampling lines when they, at their compression fittings, lines degrade, things fail. You can have absorption. Sometimes you can get material in there that also causes, such as lime, if you have a bad filter, you can have material collect in your lines, or they can collect on the filter, and that can also cause scrubbing. Your conditioning system could be leaky, faulty, not have enough movement through it, and you could also just have bad calibration error. So some important notes. The certification of SEMS are provisional until approved by the administrator. So when you go through when you complete all of the steps for your certification, you have to submit all of the information to your state agency and to the EPA. Once they give you approval, then it is officially certified, but that can take up to I think it's 140 days. All steps must pass. It is recommended that you do the RADA last, while you can do a RADA in the middle of your 7-day drift test. If you fail your 7-day drift test, then you have to reconduct your RADA. So that's why it's recommended to wait until all of these steps are completed, and then you conduct the RADA. Recertification is required when there is a modification to the sampling system or analyzers are changed. If you have to replace tubing, replace a probe, replace an orifice, there are many qualifiers in there that help you determine that. Equally as important is in the United States, in Part 75, it is required to have an air emissions test body accreditation. So any test team that comes on site to conduct a RADA test for your facility has to have an accreditation. An AETB is a team that performs stack tests and demonstrates conformance with ASTM D7036-16. And these are the criteria with which they have to conform. And this is based loosely on 17025, ISO 17025. It also requires a qualified individual or qualified source test individual, those are two separate things, to oversee the testing program. To become a QI or qualified source test individual, you actually have a series of tests. So there are right now currently 6 tests that you can take. You don't have to take them all. It kind of depends on what your area of expertise would be, but they're broken into categories based on the type of testing that you're going to perform. So this is an important program because what it allows you to do is actually know that the person that's coming to oversee the testing understands what needs to happen to make sure that the test is of high quality. So now, does anybody have any questions on how we conduct emissions testing or our SEMS? Okay.
since you people are not asking any question, so some of the questions from this session, from the presentation is in the assessment sheet. So beware of that. You still have a chance to ask some questions. I understand a little bit you might have that problem with understanding with the different pronunciations and different tone, but still you tried. So he spoke you about quality assurance system in US, what kind of tests are being done. We are used to uh, have information and knowledge of more of European system, right? Because most of the suppliers that we have in India are from the Europe, Germany, UK. So we understand qual system, we understand EN 14181, all those things. So US system is a little bit new, but we need to understand because you also have the performance test for the non-certified system, which is our guideline requires. So you still have a time, you have 2 days. So if you understand a little bit, you have some questions in between, you please certainly ask. So next is, I think that will be your favorite again, because it is about the European system of quality assurance and control. That will be taken by Roland Jepek. Seeing Roland itself, you can figure it out. He has more than 40 years of experience. He has worked tremendously on gaseous system, combustion system. He has developed some system as well. And he is involved in too many things. One of the world's leading suppliers and manufacturers of technology as well. So if you'd like to share something about himself, that's most welcome, because I have a lot of things to talk about. I'll leave on Roland. And please again, just do ask the questions. Figure it out.
Thanks, Sanjeev, and welcome after lunch. Wake up, wake up. Don't digest, digest here in the brain. Okay, can I get a presentation, please? So we're now looking into the European system. What are we doing in Europe? It's Bhopal Qual, QAL. Yes. Right. How we do things in Europe, which are to some extent similar to the US, to some extent different. And there are some major differences. Okay. Oh, yeah, okay. I'll take this one because I like to walk. Otherwise, I fall asleep. That one you know. And there are many places in a power plant where we can do monitoring, which are all process monitoring positions. And then there is the legislative monitoring, which is required. And that is what we are talking about now, monitoring in the stack. Europe, we follow the EN 14181 scheme, or the so-called QAL scheme, quality assurance level. That starts with Qual 1. Qual 1, this is the major difference between the US system and the European system. Qual 1 is an instrument type approval, meaning the manufacturer, here, that's the manufacturer, has to give 2 sets of instruments to an accredited laboratory or testing institute. TUV in Germany or CIRA in the UK, which is MCerts, then the MCerts approval. And they do a laboratory test where they do linearity, interferences, temperature drifts, span drifts, etc., etc. very extensive. And if the laboratory test is passed, then these two instruments go to the field and they're installed in a power plant or a cement plant or waste incinerator, depending on for what type of industry do I want my certification. And then they run there in parallel, compared with standard reference methods over a period of time. And Sanjeev already mentioned that. That can take 6 months, 8 months, 10 months, depending how good the instrument is. And very important, the manufacturer has no allowance to go to the system during the testing period. So if they go to the system because there is a failure or they have to repair something, this goes negative in the availability of that instrument. And instruments must have an overall availability of 96%. And overall availability means the 4% non-available grace period includes calibration and maintenance and service. So you can be dead sure an instrument which has passed Qual 1 certification in Europe is a very good instrument, and it delivers reliable data and gives you not a lot of headaches during operation. Then, and now a company needs to install systems. They install a system, but they can only install Qual 1 certified analyzers. If an instrument has no Qual 1 certification, you cannot use it for regulatory monitoring in Europe. Not like in the US, you can use anything as long as you prove that it works on your stack. Europe, only Qual 1 certified instruments, and at the stack after installation is then Qual 2. Qual 2 means similar to RATA. Qual 2 is, there is tested or checked the installation by itself. Is it at the right position? Is there enough time, 5 times or 8 times D before and 2 times minimum after the point, the tapping point? Is the system built correctly? Are the heated sample lines laid correctly? Do they have the right temperature, etc.? Plus, of course, runs and calibration comparison with standard reference methods. Minimum 15 measurement points with a distance of more than 1.5 hours between each sampling point, and the whole thing over 3 days and over a period of 8 to 12 hours per day. And if the system now has passed, fine, off we go and we monitor. And then comes Qual 3. Qual 3 is the manufacturer suggested maintenance done by the user, by the operator of the instrument, with certain maintenance cycles, and minimum 1 zero and span drift test per maintenance cycle. And the maintenance cycles, the suggested or allowed maintenance cycles are defined Qual 1. So that is very clearly defined. What is the cycle? How often do I have to do any maintenance on my system? Once per year, an accredited laboratory comes in. Oh, very important. And everything, every step, what is done at the instrument has to be documented. Once per year, an accredited laboratory comes in and does the AST, annual surveillance test, which is a short form QAL2. So it includes the same tests, but in lesser quantity as QL2, and they check if QAL3 has been done correctly, if the documentation is complete, etc. If AST goes perfect, off for another year. After 5 years, a QAL2 has to be done. So QAL2 has to be repeated every 5 years. If AST fails, for example, the documentation is not complete, immediately a complete QAL2 is required. And QAL2, of course, is significantly more expensive than an AST. So this brings the operators to the point that they really take care of their instruments and their systems. So, QAL1, instrument type approval. The big difference between European system and US system. So, jumping to something different, you write tender documents, you write specifications. Don't put in your specifications US EPA certified instruments required. That is not existing. You can put in EN certified or QAL1 certified instruments required. That is existing, but the US EPA certified instrument is not existing for emission monitors. There is no type approval. For air quality monitors, yes, there is US EPA type approval, but not for emission monitors. And what is certified, you find on this page, and there is another page, but you will get all the presentations later on, so you find these links then in your information packages. QAL2 is the site acceptance test performed by an accredited laboratory. Testing for the quality of the installation, sample handling, etc. And as I said, only QAL1 certified instruments are allowed to be used, and QAL2 has to be repeated every 5 years, sorry. QAL3, ongoing daily assurance, 0 spend checks in the maintenance cycle, regular maintenance. Typically, I mean, I don't know any manufacturer who not says do a 0 spend check every 23 or 25 hours. Why not every 24 hours? Question. Who can tell me why it is not smart to do a 0 and spend check every 24 hours? No? Then you are missing exactly the same time frame every day in your data. If you do it every 23 or every 25 hours, it's shifting. And you're not missing the exact same time frame every day. Just a little practical hint. On the other hand, of course, if you do it every 24 hours, in this time you can emit like hell because nobody recognizes it. No, we're not into that. AST, annual surveillance test, short-term QL2, accredited laboratory. If it fails, QL2 has to be done immediately and not only after 5 years. So we have that scheme, QL1, QL2, QL3, AST. This part, QL2, AST, QL3, you as operator, as owner of a system, you have to pay for that. This one, the manufacturer pay for it. And as Sanjeev mentioned, it can be heavily expensive. Just to give you a ballpark figure, if a QL1 certification is for a simple type of instrument, I'm not talking about a total mercury analyzer, but just normal UV or infrared or FTIR or something like that, we're talking about 60 to 120,000 euros just for the test. So if everything runs well, and I know tests which had their problems, and the bill was easily going over 200,000 euros. So we're talking about big amount of money for the manufacturer. So a manufacturer must be dead sure that his instrument is good and will pass. Otherwise, they're just blowing money out the chimney. So again, QAL1 existing under EN regulation in Europe, nothing comparable existing in the US. It's based on EN 14181 and sub rules is the EN 15267, which includes general information and assessment, and the test procedures, which are in sub-parts for stationary SEMS, for mobile SEMS, for qualitative dust monitoring. Quantitative falls under SEMS, qualitative falls under separate performance criteria, and then the data handling and data acquisition requirements. Data handling and data acquisition systems also have to have QAL1 certification in Europe. That's the two sides. The top one for QAL1 certified instruments, the bottom one for the MCerts certified instruments. And as I said, you'll get the handouts, or you can download that later on, and there are the links in it. QAL2. And oh yeah, both certifications expire. So they are not forever. If an instrument is certified and over a period of some time, and it is written in the certification paper, and Sanjeev showed some examples for a QAL1 certification. There is the front page. On the front page it says when it was done and what is the instrument, etc., etc., and when it will expire, and then the important pages start. And I mean, as Sanjeev mentioned, I worked with instrument manufacturers. We tended to give the first page if somebody asked for a certificate. We don't give the second, third, fourth, and fifth page. But you can all download them from the QAL1 homepage of TUV, because on the next pages comes the limitations. Under what circumstances can it not be used, or what has to be looked after. There comes the sensitivities and all the detailed information. For example, for emission monitoring, QAL1 certification for an emission monitor includes the data handling and sample conditioning system, not data handling, the sample handling and sample conditioning system. That is an integral part of the QAL1 certification. So if this is my analyzer, and this is my sample handling system. They go together for the certification. If I decide, oh, this sample handling system I like more, sorry, that combination is no longer Qual 1 certified. It's only this combination. And they,
Sir, suppose there is a certain model by a certain manufacturer. If it is installed at one site, it is having QL 1 to all certification. And if the same model, another unit of the same model is being installed at another site, will it require a separate certification?
Qual 1, no. Qual 1 is a type approval. Qual 2, yes. So, Qual 2, that is the site calibration every 2 years. And it includes a number of activities at site. How is it installed? How are the sample probes laid? How are the heated sample lines laid? What are the temperatures it's running? It does functional tests, of course, parallel measurements for against standard reference methods, and the standard reference method which is applicable is defined in the environmental permit for that very specific site, and the data evaluation, calculation of the variety, etc., etc., and of course storing of the Qual 2 calibration data then in the data handling system or in the data acquisition system, depending on how it is built. And all of that has to be done by an accredited laboratory. Qual 3, as I said, the normal activities, maintenance activities as suggested by the manufacturers. Very important, complete documentation of everything. And in my opinion, the best way to be on the safe side that your instrument or your instruments, what you have installed for SEMS monitoring, work perfectly is to get an annual maintenance contract, sign an annual maintenance contract with the manufacturer, so that the manufacturer takes care at least once or twice, as it is defined in the contract, about the complete ability to operate perfectly of the instrumentation. When we're talking about very expensive pieces of equipment, and the annual maintenance contracts are relatively small in budget. But that gives you the assurance that your instruments work perfectly. Sideline, I'm not selling AMCs.
I have a query, sir. For annual testing, we have to send the whole system to the manufacturer end, or
For AMC, no, they should come to your stack.
site, how they calibrate their sites?
Pardon?
At site, how they calibrate site?
The manufacturer has the ability. Shravan, I think you're a good person to answer that.
What we do is when the maintenance engineers are at site, so they carry out the basic maintenance the instruments like cleaning of its lenses, whatever it is there. And if any calibration is required to be carried out for the analyzer, they can take the instrument down to the laboratory, and in the laboratory we assure like there will be a clear path and we can perform the calibration there.
Laboratory not available at our site.
No, this, I mean to say the site laboratory means instrument workshop. Okay, we can take the instrument to the workshop, down the stack. And the place where there is no dust, there we can take the instrument and we can calibrate it and we can keep it back again. And it is not required every time to send the instrument back to the factory for the calibration. We can do it at the site. And the engineers will come with the respective tools and all the setup with them, and they do the maintenance. That's why Roland has addressed, like, though the manufacturers can have the AMCs, they can come with the respective tools and can carry out the maintenance easily.
Thank you. I mean, he is in service, I'm not. So. But this is what he said for his company goes for any other manufacturer, exactly identical. So. AST, annual surveillance test, short-term QL2 with, as you see, less points to be done, functional test, some few parallel measurements with standard reference methods and calculation and variability, and very important, number 6, the reporting, and number 7, the completeness of the documentation, so that the accredited laboratory knows that you have done your job during the year of operation. And as I said, again, if AST fails, then a complete Qual 2 is required immediately. That's the system as we run it in Europe, as we do it in Europe, and as it operates. And for Europe, I also include the UK, even that they are no longer part of the European Union. So are there any questions? Jean?
So if you remove the instrument and send it back to the factory, then it's fixed. How does that handle that?
If they move the instrument back to...
The repair of the instrument requires it to be removed and shipped back to the factory.
Yes, that goes into the 4% availability of the instrument. Meaning, in critical installations, there are redundant systems installed. Or the manufacturer comes with a replacement instrument for the period of repair. No, I think there is no.
I'm just saying in the United States we have 30 days.
Yeah. No, I'm not sure if that is limited. I don't think so. Any more questions? Yes, please. Qual 2. What do you mean with define? That's okay. Number 1, it has to be done by an accredited. Number 1. Number 2, of course, it is different for P as it is for gases. Slightly different. And I say slightly different because for PM, I have isokinetic gravimetric sampling over a period of time. So and to say it very simple, I collect sample for, let's say, 30 minutes, and I take my reading of the analyzer for the same 30 minutes, and average that over the 30 minutes. Get from my reference method is my concentration. It's my calibration factor. And for gases, depending on the gas, is the standard method defined, whatever. It's all wet chemistry methods with laboratory analysis, and again the same sampling over a period of time, and at the same time measuring with the analyzer and averaging the measuring signal over that time. they're all different. They're all different for the different gases. For CO is different. Is a different wet chemistry method. For example, for okay, I only comes only to my mind a non-stack component ozone. It's potassium iodide method. So there are wet chemistry methods. I can get you that, or you find that on the QL homepage. I don't. No, it's a wet chemistry. All reference methods are wet chemistry methods. It's not another analyzer. Yes.
And that's a big difference from the United States. So the United States, when we do reference method testing, we do reference method testing using gas analyzers. So you would use CO gas analyzer to an SO2 to a NOx. Those analyzers are what are being compared to the installed system, right? So Stack Testing Company brings out a trailer that's got a full rack of instrumentation, just like you would expect to see, although it might be different, and we don't have the, we have more flexibility with the instruments that are installed on site, but we do not use, it's very rare to use a wet method for SO2 or NOx or something like that in the United States. It's all instrument to instrument. We string up the sample lines, they run all the way up to the top. It's a very similar type of a system that you're using there.
Just a clarification. What's that? You use
Yep.
the gas analyzer, calibrated gas analyzer as a reference. Yes. But now this gas analyzer or this gas would have been calibrated with the reference.
They have been calibrated in the laboratory against the wet method, and they are the transfer standard.
Well, yeah, for the calibration.
Yes. Yes. Yes.
Again in the GC you use a standard. So anything you use, you have a reference. Correct.
And the gas analyzers are the transfer standard from. Yes. 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 Against the reference method. So it all comes down to that. Whether I use a transfer standard, whether I use analyzers as a transfer standard. At the basis, it comes down to the very old wet chemistry, very standard wet chemistry methods. Any more questions?
Sir, this QL1 is limited to only analyzers only, or it can be as a certification for the sample handling also?
Analyzer plus sample handling system. So you cannot go for a QAL1 only for an analyzer unless it's an analyzer not requiring a sample handling system.
But practically what happened, the analyzer manufacturer is some XYZ company and the sample handling system is being supplied by some another company. So how these combination can be utilized for this QAL1 certification?
Oh, only if they so analyzer manufacturer A uses sample handling system from sample handling manufacturer Z. And with this combination, A plus Z, they do the they get their QAL1 certification. Now, you as a user, you cannot, if you strictly follow QAL1 certification, you cannot use analyzer A with sample handling system Y. You only can use it with sample handling system Z, which is a little problem manufacturers of sample handling systems. Somebody comes out later, for example. Very difficult to install their system unless they find a manufacturer running a Qual 1 certification. That is strictly according to the rule. Even in Europe, we can bend rules. So it might be accepted by the laboratory that a different sample handling system is that. Qual 3 is the day-to-day maintenance, etc. And yeah, you not the life of the instrument, but you prove that the instrument operates correctly and that it measures correctly and that there is no calibration drift, no zero drift, and everything works according, and filters are changed and diaphragms are changed as the manufacturer suggests it.
What may be the maximum life?
Maximum life of emission monitors, I would put it at 10 to 15 years. That's the typical lifespan of an analyzer. But and it all depends, as Sanchev says, it all depends how you handle the analyzer, how it is kept, if it is in a nice air-conditioned shelter, clean and maintenance is done on a very regular base. Even here, they can live a little bit longer. Yes, yes, absolutely. That's always. Any more questions? With calibration gas? For dust? For PM? PM manufacturers typically provide reference filters. If it's a light transmission instrument, opacity monitor, there is a transmission filter what you put in and it absorbs, gives you a certain certified absorption, and they're simulating a certain concentration. That's PM, yes. And for gas, it's gas bottles, calibration gas bottles. Either you have calibration gas bottles with various concentrations, or you have higher concentration, and then you have dividers and produce your own through capillary dividers, produce your own calibration gases with lower concentrations. Qual 1 is a basic test of any function of the analyzer. That's a laboratory test. Very extensive laboratory tests typically go 3 to 4 months, 24/7. Temperature drifts, voltage drifts, calibration drifts, of course, zero drifts, maintenance cycles, sensitivity, cross interferences. I mean, from A to Z, completely everything, what you can think of. And testing institutes are very creative in finding a lot of tests they have to do because it gives them a good turnover. Any more questions?
Sir, one question I want to ask. Here.
Oh, sorry.
Sir, we just encountered certification programs from USA and European Union. And, in your opinion, which is more suitable for India? I think European Union is more suitable, no? Because
now, Sean, now they are grilling us. Let me put it diplomatic. Your CPCB has decided to apply both possibilities. And I think as Leslie mentioned this morning, in the leapfrog we're seeing here in India, and I mean, I'm coming to India since '86 on business. So I have seen a few changes in the country. And in the leapfrog, what you're doing in the technology, defining something strictly Indian just doesn't work in that short time frame. So applying both and allowing both is, in my opinion, a very decent way to go. You don't have a certification from India yet. If there will be a certification process in India, that will change. Then, because it depends on, I don't know, I'm not part of that development, but if that is a type approval, then it is the European way. If it is a site approval, then it's the US way. Completely clear. I said, yes, I said yo, yes and no. Any more questions? Okay. Yes.
So it's
Likely to be type approved. Here comes the guy who looks under the tablecloth. Okay.
So there's one difference when Ronald came here in '86, you were young, and now it is old. That's the major difference.
Thank you. Now we should probably tell them that we both know each other since 46 years. And we're going along with each other since 46 years and haven't killed each other yet. Okay, any more questions? If not, then thank you very much.
Ready?